Alright, we're recording. So, the example is to prove, and you guys should take notes on this. Okay, I know you're going to be able to watch it. But what we're going to do is prove that the series starting at n equals 0, going off towards infinity, of x to the 2n over n factorial quantity squared converges for all real x. So this is an example of it converges everywhere. Okay. First thing we're going to do in the solution is set up and define some things. We're going to have that x is any real number. Which way?
Just a little bit towards there. There we go.
Oh, there you go. Okay. Now the series that we're working with, again, we're trying to define this, so that the series starting at 0 going to infinity of x to the 2n, sorry, that's a 2, over n factorial squared is, first of all, non-negative. This is a huge criteria for the direct comparison test. Okay, let me just flash this back up. And you can see this in the video. The only criteria we have to have here is that you have non-negative terms. And so that's what we're going to say right off the bat. There are no negative terms here. And that's because take any number, raise it to an even power, positive. Take any number, raise it to an even power, positive. And these are even factorial, so guaranteed to be positive. Okay. So maybe we can use the direct comparison test. What would you guys want to compare this to?
Wow.
Now for any n, it looks kind of like cosine, right? Can we, except cosine alternates, right? To me it kind of looks like e to the x a little bit. So let's try and compare it to something like that, okay? We have x to the 2n over n factorial quantity squared is less than or equal to, you guys agree, x to the 2n over n factorial, which is x squared to the n over n factorial. And now you can recognize that this series from n equals 0 to infinity of x squared to the n over n factorial as, anyone? What's replacing the x for e to the x there? The
E to the x. That was a lot. Yeah, I don't know. E is replaced by an x.
if you look back at the Maclaurin series, e to the x is x to the n over n factorial. In parentheses here, that's what's replacing the x from e to the x. So let's replace it here. Okay? So we've said it's less than or equal to a convergent power series. So what do we know?
That it converges.
Yeah. Which we know converges I'm sorry, for all real x. And so we're going to make a final statement. Now since e to the x squared dominates, our original series, and dominates it term by term, the later series converges. Not only converges, but converges for all real numbers. By the direct comparison test. There's your little QED box. Try and fit it all in here. That's about enough of it to get the whole picture.